Hello, this is Proshun Datta. I am here to present my design of a 4-bit PC using VerilogHDL. Let's have a quick glimpse of the design architecture. There are basically 5 main blocks. They are input register, output register, memory unit RAM, stack memory, instruction execution unit. There are 2 input registers. They are called A and B. They are of 4 bits in size. Eventually, there will be 2 output registers as well. They are also 4 bits in size. And then comes the RAM. For constructing RAM, a 2D array was declared which will have 16 rows and each row will be 4-bit long. We have chosen this size to have an essence of SAP architecture. Then comes the stack memory, which will be needed to store values. We have created a stock memory which has size 16 multiplied by 4. Then comes our nucleus of the architecture. This is called the instruction execution unit. It is the instruction execution unit which consists of 16 modules and each of them perform their specified task. We have basically 3 unique features in our design. They are zero flag, carry flag, and stack output register. Zero flag becomes 1 whenever you get any 0 in the input or output register values. Zero flag remains 0 otherwise. Now comes the carry flag. Carry flag is necessary in the operation of addition, subtraction, as well as in rotation, shift, etc. Whenever a carry is generated, the carry flag becomes 1, otherwise it will remain 0. Then comes the stack output register. This is a dedicated output register which will show the current content that is pushed or popped in the stack memory. This is the carry flag, this is the zero flag, and this is our stack output register. Then comes the instructions performed by this PC. This PC will perform these 16 instructions. They are add, sub, exchange, RCL, etc. Here A equals to 5 and B equals to 4 are taken in the input register. Then PC INSTR is the opcode for instruction of a given task. The clock pulse has a period of 10 nanoseconds. Every time the clock pulse gives a positive edge, the PC INSTR variable will update its value by 1. This PC INSTR variable will trigger different case module to perform different tasks. Then comes the address. This is basically a pointer to access the data stored in RAM. We'll use this as an index to access memory data that we have assigned. Here goes the explanation of the instruction. PC INSTR equals to 0 will perform the addition operation and the result will be stored in my PC output A. Then comes the subtraction operation. The result will be stored in my PC output B. Both in this operation no carry, so carry flag will be equals to 0 and zero flag will be equals to 0. Then PC INSTR equals to 2 will perform the exchange operation. B will have values of A will have values of B. Then comes the rotate carry left operation. So the pattern of B will be 1 0 0 0 0 or 0. Then in this operation, MSB will go to CF, and then CF will take place in the position of LSB. This instruction is SHRA, so LSB equals to 1. This will get shifted to CF, so CF equals to 1, and 0 will come in the position of MSB, and so the change bit pattern is 0010. This instruction will move the content of address 0110 to the position of A. This instruction will perform the bitwise XOR operation between the content of address 0111 and A, and the result is here. Then comes the logical AND operation between A and B, and the result is stored in A. Then comes the OR operation between content of address 1001 and B. The result is stored in B. Then comes the output instruction. This will output the value of A. This is jump if 0. If we get 0, then IP will store this address. Since we have no 0, so IP will be unchanged. This is push B. B will be pushed in the stack. SPE will decrease by 1. And this is pop B. B will be popped out of the stack and SP will increase by 1. This is call address. Here IP will indicate the value 1110. This will store its previous value in the stack, so SP will decrease by 1. This is return address. So IP will retain its previously indicated value from the stack, and so IP will now indicate 000 address. This is the halt function. It will stop the program, so stop flag will be equals to 1. Thanks for your patience.